Good morning, good afternoon to everyone. Welcome to today's TMS Tuesday. It is our 42nd TMS Tuesday, and today we're going to be looking at managing visual aids compliance in the 21st century. And to just so everyone knows, we've got a panelist which is very global today. We have on our panel, we have Tony Smith, we've got Rob Billingham, we have Tony Coates, who's actually not listed on your sheet. We have Nick, we have Seward and Carl, and obviously myself. So I'm going to hand over to Rob, and we're going to have a look at visual aids.
Thank you. Hello, everyone. Good afternoon, good morning, good evening, wherever you are. I'm Rob Billingham. I'm Software Development Manager for TaylorMade Systems. I've been with the company for 10 years. Most of that time, I've been developing the MALMS dashboard system, which I hope many of you have used. And I've prepared a presentation on visual aids in the 21st century. So move on to my first slide. Okay, so the MALMS CMMS. So we're going to talk about the advantages of a cloud-based asset management system. So have you ever wondered how a CMMS could streamline your operations? First of all, what is a CMMS? So it's a good question. Until we know what it is, we won't know what the advantages are. So it's computerized maintenance management system. So it is software or a whole suite of software which helps companies manage their maintenance information and processes. So the ultimate goal is to boost equipment uptime. So in our world, this is the airfield and all of its assets, its AGLs. What is CMMS? So it's not new. It's 60 years old. Back in the 1960s, IBM developed a punch card system using a large mainframe computer. Punch card readers, where technicians would use the system to remind them of routine maintenance tasks. Then in the 1980s, computers became smaller, more affordable. Everyone got them in their homes, and I'm sure many of you have lived through all of this. In the 90s, they began to get more connected. Everyone's connected to local area networks. And then in the 2000s, suddenly everyone is connected to the web, the cloud, mobile devices, tablets, 5G SIMs, and CMMS has come into its own. So the latest generation of CMMS, it has greater functionality, it's faster, easier to maintain, with hopefully got greater data security. And it's suddenly, the cloud is becoming a part of our lives. It's definitely part of the future. Everyone's phone connected to the cloud, backs stuff up into the cloud, and it's become very much part of our everyday working lives as well. So a CMMS system, lots of them around, but they all have core components which are common. Most important is a core database which contains assets, details about equipment, materials that we use, and other resources. So for assets, the database contains things like their location, their ID, maybe the manufacturer, the equipment type, etc. Materials might be in our photo bench in our workshop. We track materials used like lenses, cables, bulbs, filaments, etc. Equipment, we might store details about vehicles, trailers, torque wrenches, and other resources. So we've got all this information in our core database. Then we need some sort of asset management system to maintain that data. We need forms to enter new assets, maintain the ones that are there already. Then work order management. Okay, so we've got faults we need to fix. We've got maintenance we need to do. We need to get those requests down to the engineers in the field. So we need the system to generate work orders, pass this information on. And in order to do that, we need, in the first place, we need to plan our preventative maintenance. So we need a system that can do that, to create those schedules and get those tasks down to the engineers. In the photo bench workshop, we need stock management. So we've got AGLs on the shelf, spare ones, and then we've got parts which we need to make sure are in stock and track them. And then audits. So first thing is we need to report to the regulators, which we'll see shortly. We need reports that can be passed to them to prove our serviceability. We also need, at the management level, we need to be able to create KPIs and reports for managers. And at the engineering level, we need reports that can be used for diagnostics. Okay, so in the MALMS system, we have a cloud in the middle, and we started off with our MALMS Engineer system. But every part of the MALMS system connects to this cloud, and we've got this 4-process system, which I'll just briefly discuss. So we've got to measure, maintain, monitor, manage, and then back to measure again. So we go around in a circle. So measure, in the first place, this is collecting data. So this is our trailer, our luximeters, our Sinopapi testers, our workshop testers. All the information from those surveys and tests go up to the cloud. Then this data goes into the next phase, which is maintain. So what do we need to fix? What do we need to torque? We need to clean lights. All of these maintenance tasks are based on what we've measured. Then we pass this information on to monitor. So the dashboard system. So here we can look at the effectiveness of our maintenance. Is it working? Can we prove our serviceability? And then on to manage. This is analytics. It's our top level management reports. It's our reports for the regulators. And the results of all of that goes back around again, back into measure, where we start again. And our motto is, you can't manage what you don't measure. So if you don't measure anything, we don't start at the beginning. So I'll introduce MALMS Cloud, hoping that many of you already use this. So it's a cloud-based system that brings together all of the components of the MALMS system. So we've got the top level dashboard, which pulls together all of the data. We have our photometric system, the trailer, the MALMS Engineer system with its torque wrench, its faults, its inspections. We have the Sinopapi tester. We have the luximeter, which is the apron tester, and in the workshop we've got our Photobench Engineer system. Okay, so MALMS Cloud itself, it's a physical server, and it lives in the UK, and it's provided to us by a company called ANS, and they're located in Manchester. So they are PCI and ISO accredited. So this is a professionally hosted package. They boast redundant power, advanced fire suppression, and advanced cooling systems to keep that server running. They support it 24/7, 365. So you know, if we're not available, that server went down, they would have it up and running within the space of about 4 hours. And they say they have 750 plus IT professionals available to us for assistance. So on the right-hand side is a top-level diagram of the MALMS world. So we've got the cloud in the center, running on a physical server. So that is behind a firewall, which protects it from everything that's wrong in the internet. And then through that firewall, our tablets connect to it. So for photometric surveys, for MALMS Engineer, PCs for the photo bench. And then there's management level PCs like MALMS Office PC for configuration and reporting. And then there's the dashboard connection, which is a web-based application available on a PC or a phone. So all of this connectivity is via Wi-Fi, 4 or 5G, wired connection. So what are the advantages of a cloud-based system? So it's secure. We use a variety of secure securities to protect our data. We've got HTTPS protecting the cloud, the dashboard reporting. So when you run the website, you will see the padlock symbol on your browser. We have WebDAV protecting our file transfers between tablets and the cloud. We have encryption with our SQL database. We have a Cisco firewall protecting the server itself. And we have basics like antivirus running on the server, denial of service protection, all sorts of advanced monitoring. And most importantly, we have backups. So the server is backed up by ANS every 24 hours. Then also we do at the other end of the day, so it's every 12 hours in effect, we back up all the customer databases ourselves to our own server, so we have that extra level of protection. And support, I've already mentioned the support from ANS, they're 24/7, but as MALMS support, we can see what you can see. We can look at your logs, we can connect into your tablet PCs using TeamViewer. If we're doing commissioning work with you, we have access to your database and we can put changes live straight away. So the cloud offers a much higher level of support than a closed network. Then the MALMS dashboard itself, so it's a secure website. It is a business intelligent and an analytical data visualization tool. There's a mouthful. It displays KPIs, management level reports, engineer reports. All of your data is there within the hour if you do a survey. You can see data in a variety of views, from the dashboard to maps and calendars, and there's all sorts of reports, a whole library of reports to see your data on all the different parts of the MALMS system. More about that later. And then analytics, again, using those reports and the statistics available to solve problems and look for ongoing faults. Email, you don't need to log into the dashboard to see your survey test results. You can get them emailed straight to your inbox, so you don't need to log in. They're there to see while you're having your breakfast. And then system integration, we can integrate with various third parties. In the past, we've looked at Maximo, Oracle, various different asset management systems, and we can export our data into SQL, XML, JSON to get your data into other packages, or even just manipulating spreadsheets for yourselves. Then audits, your compliance demonstration. If you're going to do all this lovely maintenance, you need to prove that you've done it to someone, particularly regulators, ICAO, FAA. The reports are respected and in fact developed with these regulators, so they expect to see what they're seeing. Okay, so next we're going to look at dashboard reporting and how we can use those reports to manage your compliance. So when we log into the dashboard, we see a lot of information. The dashboard itself is divided into panels, and each one is an aspect of the MALMS system. So we have Photometrics, we have MALMS Engineer with its talking and its faults and its asset status, Sign and Pappy, Luxometer. Each panel is divided into geographical areas, runways, and each has a status. So it's either unserviceable, or hopefully it's serviceable to Cat 1, Cat 1, 2, 3. The dashboard is user configurable. So you can decide what is shown, and different users may have different views of this data if they're not interested in all of it. There are icons where you can drill down into reports from each area, which one I carry on to look at. So if we're interested in photometrics, the set of reports starts at the dashboard by runway, and then we drill down into runway serviceability, course bar charts, and then Isocondenser diagrams. So we shall see the benefits of each shortly. So the benefit of using these is to maintain your high-level serviceability. And as I said, there is a whole library of these reports to view. Runway serviceability then, here we have our two runway directions, 0624. If it's a big airport, you've got a bigger panel there with all of your different runways. We can see we have one unserviceable runway and one that's can be used up to Cat 3. We have a warning badge there with a streak mark. This is telling us that there is currently some adjacent failure within service somewhere inside 06. So we drill down from there to see what's going on and where that is. So if we click on one of the report icons, we drill down to runway serviceability for that runway direction. So this is a top level photometric report. It's broken up into services. So we've got the centerline, the edges, TDZ, threshold, and the runway end. The y-axis is the percentage of serviceability. So this is the percentage of lamps which are above 50% of standard, so which are passed. If you are above 95% on a centerline, you get a nice green bar. If you're below 95%, you may have a lighter colored green bar, which indicates you're only Cat 1 compliant. Below that, you'll have a red bar, which is unserviceable. Maybe though that you have a higher score, but you still have a red bar, which indicates there is some adjacent failure, two or more lamps together, which is an instant failure on our serviceability. If we click on a service, we drill down again into the course bar chart, which is a staple report of any photometric testing. Many of the engineers will recognize. Each bar represents a lamp within that course on the runway, and the data is presented in the order the pilot will see it, from left to right. So we're looking for green. The green is a pass. Blue is maintenance may be required, and red is a fail. So if you're IKO, 50% is your pass mark, and 70% is your maintenance level. If you're FAA, this would be 70 and 80, where the bar is set even higher. At the bottom of the lamp, at the bottom of the bars, you can see the lamp color. So on the left, it's an edge, so you can see the red lights going along to the whites, and then the yellows on the right. You can see some little black bars in there as well. That's must be a spacer or a lamp that's not there. But we indicate those. If you click on a particular bar, we go down into Isocondenser diagrams. So we show the Isocondenser for both sides of the fitting. It's because you should read the diagram as a whole and see both sides. This may show you a problem which exists on the fitting as a whole. So in the text above the diagram, you can see the candela value and the percentage of standard. So you can see here, this one is 49%, which is just short of the 50% pass rate. We show that in red, or one that's at maintenance level, we show in blue. So on the diagram, the y-axis is elevation, and the x-axis is azimuth. So these are all measured in degrees. The ellipse is where we expect the brightest part of the beam to be. So this is defined by FAA or ICAO in their specification. And if the lamp is correctly aligned, we should see the brightest part of the beam all within the ellipse. And this is the area where we average the results to produce our overall candela and percentage of standard figures. So on subsequent pages of this report, and depending on what you set your from and to dates at the top to, you get historic data. You can click a link in the bottom right corner for an historic trend. And here well, there's two trends. There is a trend to time to clean the lamp. So how long does it take till it gets dirty and it needs to be cleaned? But there's a second trend, which is how long does it take until it fails and you have to relamp. So this diagram can be used to estimate those periods, and then that can be used to adjust your preventative maintenance schedules in an intelligent way. And later we'll see how we can combine that information with information from MALMS Engineer, where we know when we've done cleaning and we've done relamping, and we can add that to the diagram as well. So then we're on to analytics then. What features have we got within our CMMS to allow us to investigate problems and analyze statistics? So we've already mentioned isocandelas, very important diagrams. We've already said what the axes are. Each pixel within the diagram is a sample from one of our sensors, and we color code them in using a particular palette. So here we can see the brightest color is the ice score, going down to a darker red, which is the lowest. And we've already mentioned the ellipse, which is where that bright part should land. So if we look at some good results, this is an edge light towed at 3.5 degrees. We can see if it's aligned correctly, we've got the light blue area within the ellipse on both sides of the diagram. So remember, the towed fitting means it's pointing in towards the center line. So if we got poor alignment here, we've got a light that's aligned too high. See, the bright part of the beam is hitting above that ellipse there. This problem could be the can, in which you haven't got much you can do about that. If it's an elevated fitting, you could possibly have some adjustment on it, but the can itself, it may need adjusting in the tarmac. So we've got another case of poor alignment here. This one is twisted by about 6 degrees, and we can see a bright part on the right-hand side, but nothing on the left. So misaligned fittings may be bright enough to pass, but they will fail sooner, and they won't be visible to the pilot at the correct angle. At the bottom, another example of poor alignment. So we've got at one side we're pointing down into the runway, and the other side we're pointing up into the sky. So we've got a fitting that isn't level. Okay, common mistakes. So we can look for these in isocandela diagrams. Here we've got a case where we can see the bright parts on both sides. So is this lamp in the wrong side of the runway? And the one at the bottom, we've got a fitting where we can see a bright part around the y-axis, so in the center. So as someone puts a centerline fitting into a TDZ can, another common mistake. Something else you'll notice on the TDZ fitting isocandela is that it's aligned slightly higher. A TDZ fitting will have a much higher elevation than an edge. Internal mechanical issues, not much we can do about these. It might be a back to manufacturer job. It might be something you can fix in the workshop. It'd be an internal alignment or something. But you'll get some diagrams where neither side makes sense, like this. If the light is completely out, it's a dark isocandela, but never completely black, as you've got some background light from the lights behind, the aprons, the vehicle itself, or the moon. If you've got a dirty lens, you'll see a quite dark isocandela like this, but still some light. This could be rubber deposits, which can be removed by cleaning. Or it could be a damaged or pitted lens. So that after cleaning, it doesn't improve. You need further investigation. The isocandela report itself, there's several options you can use. You can change the color palette. So here changed to an incandescent palette where we've got more of a heat map. So white in the center at the brightest parts going out to red, dark red. We can add some guides to the diagram, so we can, the rulers show you where the alignment should be on the X and Y axis. And we can enhance the image. It's just a simple enhancement algorithm that blends the pixels together. We can also make a change which is called relative to beam maximum, where usually each of the pixels, the color is decided by the standard that it should be against. If we recalculate the diagram based on the maximum on this particular fitting, what is the maximum point, then we can bring out on a dark isocandela, we can bring out light spots. So that may help us look at the alignment on a very dark isocandela. Also useful on the Photobench software. Okay, so I was talking about the history of isocandela and subsequent pages here. You can see I've got a 19-page report which takes into account all surveys over a year. If I play this, I'm just clicking through. I'm about to. Here we are. Click through the pages. We can see from the very dark beginning, goes back to, in the space of 6 months, it was good. So we can see it gets progressively darker. So alignment reports. We can produce a report of the worst 30 aligned lamps, or you can configure this to whatever you want. But if you were to consider the worst 30, then you're going to make a big difference. So it may be that it's bright enough to pass. And here in this example, we can see this first one at the top is 122%, but it's failed on elevation and on azimuth. So it's misaligned. We can produce this report in isocandela form or in tabular. And as I said earlier, poorly aligned fittings may pass, but pilot won't see them at the correct glide path or distance. And as they get dirty, they will fail quicker. General repair maintenance. So after a survey, a number of lamps have failed. You can produce a report which is your worst 30, or however many you require. And if you were to go and fix those worst 30 every time, you're going to make a difference and eventually improve your reports. So another historic report is the survey history report, which is a grid of data where we look at both sides of the runway. We have our latest survey on the left, our oldest survey on the right, and we're showing 12 surveys at maximum for each side. In each cell, we show the score achieved, percentage of standard. Then we show it in green, blue, or red, same colours as the course bar chart. So what we can do is look at how often lamps are failing. We can look for repeat offenders, and we can look at problems which may not be obvious from the current data. We can also add to it our cleaning and relamp data from MALMS Engineer. So you can see the yellow line all the way down the report there is when the lamps were cleaned. And you can see a massive improvement at that point. Then we have a few lights which have still failed the next test. So we're going to change those. So a little pink box is shown on the ones we've changed. Okay, so there's still some that haven't passed after a change. So we've got some that we need to go out and investigate what's going on. It may be a circuit issue or some geographical problem that's not obvious from here. But we've got test, clean, test again, replace, test, a lot happier, and then just a few we need to investigate. A parameter at the top we can adjust, max. Here we can change this to the worst 30. So we can get this report to show just the worst 30 and we can consider their history and what's going wrong. You can also adjust the min parameter so that you only show the ones that are shown that have failed their last 4 surveys or whatever you put in there. You can export this data to Excel. So then you can analyze this further with your own scripts or graphs. Another useful report is the course bar map report. So here we're combining a geographical map with the course bar chart. And if we've got a very long center line, we break this up into 2 or 3 pages. And we're looking at a geographical view alongside the bar chart data. So you can see where the red bars are and the blue. And you can look for geographical issues, which you may not see from the course bar chart. You can adjust the map, you can rotate it, you can zoom it in and out, get it just right, save it. And if you did that on every page, you prepared a very nice report you can save to PDF. Reverse course bar chart. Okay, so here, it looks very complicated from first inspection. But we're looking at both sides of the course at the same time to look for local issues. So, so here we've got an edge line, and we can see immediately there, right in the middle, we've got one that's blue one side and red the other. So that you need to go down and look at that particular fitting. Okay, geographical representation. We have a map view, which you can look at in 2D. You can rotate it, look at it in 3D. So you can go down and walk around on the runway virtually, look at your assets and where they are and what's going on. MALMS Engineer, we've got color-coded faults, and in MALMS Photometrics, we've got red, green, and blues. So you can look at geographical trends. We can, with that map, we can do more. We've got heat maps. So we can look at recurring faults. We can see a particular fault type and where it's occurred most often. We can do the same with maintenance. So we can produce a heat map of where we've changed fittings most, where we've cleaned them most. And with torque, we can look at angle moved, and we can do a heat map of where the bolts are moving most. So we'd expect that on taxiway junctions, TDZs, any place where the plane wheels are regularly hitting the bolts and causing them to move. Then all of this we can use to plan our preventative maintenance. And time is money. We don't want to be talking lights that don't need talking. And we want to talk the ones more that do need talking. So we can focus our energies where they're needed. Okay, so rapid serviceability and MALMS Anywhere. So we've done our photometric survey, and we've got some failures, and maybe we don't retest for another month. So everyone's going to be seeing those failures for all that time. Well, what could we do to update that serviceability to reflect what we've done in the meantime? Well, first point is rapid serviceability. So this is where we start off with our MALMS mobile. We do a photometric survey. We've got some failures. So let's prepare some new fittings to swap out in the photo bench. So we've tested those in the photo bench. They've got really good results. We go out with our MALMS Engineer system and put them in the ground, scan the tags on the fittings themselves. We know where they've gone, we track it all. And those results from the photo bench are substituted into the serviceability figures until the next proper survey. So the conditions for this to work, you must have tested the light in the photo bench within the last 12 months. We don't support elevated fittings with this system because there's no guarantee that you've correctly installed and aligned them. So only inset fittings. We assume that you've got the light in the runway the right way around, with the red and white pointing the right way. You must have an encapsulated tag on the fitting. And then this brings into play MALMS Photometrics, Engineer and Photo Bench. So you must have all 3 systems for this to work. Within MALMS Engineer, we go to the light, we choose replace AGL, we do an action, we replace the light, scan the tag, put it in the ground, and then we're all happy. Then that data is substituted into the serviceability reports. So to indicate where it is, we mark bars with yellow triangles. So here we can see in runway serviceability, we have data in the center line that's substituted. And then if we drill down again, we can see exactly which bars within the course bar chart contain RSS substitutions. Another tool available to you for updating your serviceability between tests is to do a MALMS Anywhere. This is where you get the trailer out and you test just a few fittings at a time. So within Photometrics mode on the tablet, you click the Anywhere button. And then if you're out in the trailer with the trailer and you're 100 meters away from a compatible fitting, you will see a list of them. You'll select the fitting that you want to test, and then the system will direct you to that fitting. And then once you're there, you confirm which course you want to test. You confirm that the array is in the correct position for the type of light you're testing. Then you run the course with a minimum of 3 lamps. Then this information is put into your serviceability, which is updated, and everyone's happy. Okay, so measuring and demonstrating IRVR compliance. So IRVR is instrumented runway visual range, which is generally a UK initiative, but for everyone else, it's still a good measure of compliance and your continued maintenance of your edge lights and soon to be your centerline lights as well, which I'll show you shortly. So we're working to increase your IRVR rating. And to do this, we are going to prove your continued compliance with your photometric tests. And you have to do at least 4 tests a year for this to be relevant. So we average the figures from all of your tests over that 12 months on the edge lights. And you can see here on this diagram, the blue and the green are the edge figures, and they're hovering around this orange average result. And what we're trying to do is prove that we are above this 60%. That's our current IRVR credit rating. Now, this value goes into a calculation, which is used by the tower when it calculates how many planes can land in poor visibility and how many minutes apart those planes should land. So based on your maintenance, improving that compliance is actually making a difference to the operation of the airfield and the performance of the airfield. But shortly, we are going to add centerline to this calculation, which is very important. And the centerline will be added to the averaging using a weighting, which by default is 50%. And you can see that that black line is used to in that average calculation there. Okay, so it's not just all about photometrics. There's the engineering as well. There's the talking and the cleaning and inspections and fixing faults. So in MALMS Engineer, we have a variety of reports which prove that you've done all of this maintenance, and you can create a complete audit of all of your maintenance activity. So we have asset maintenance, asset management reports, faults, torque reports, cleaning, insulation resistance, whole variety of audits that you can produce. Down at the asset level, we can produce a complete audit of the history of a single asset. We can show its last 10 faults, its last 10 torque readings, its current photometric results and fault status, a complete maintenance log. We can see its photometric test results and its current Isocandela reading diagrams. and then a complete photometric performance history. And here is where I mentioned earlier, where we bring into play the MALMS cleaning and relamping data, where after a clean, you'd expect the next photometric test to be somewhat better. And then after a relamp, you'd expect it to go right back up. So we can look at all this data as a whole, and you can use this graph to estimate how long it should be between cleans and how long it should be between relamps. And then you can adjust your preventative maintenance schedules accordingly. So it's not just about AGLs, there's other visual aids on the airfield, including PAPIs, signs, and apron lighting. So we have other equipment to test these. So for signs and PAPIs, we have our sign PAPI tester. In PAPI testing, we produce test reports that look like this. We have an image of the PAPI. We produce isocandela diagrams, and we detailed beam diagrams where we can look at the transition. Results we record are minimum intensity of the white and the red, a red to white ratio. The most important is the transition angle. So this needs to be set right for the pipe to seat at the correct height. And then we look at color readings to make sure that red and white are correct colors. It should be noted that none of these parameters can be read as part of a flight test. The flight test is just a matter of opinion, but these are all scientific readings. For sign testing, so now we're not looking at a beam, we're looking at a surface of light. So we're not talking about candela, we're talking about candela per meter squared on a surface. So we're looking at recording a mean lux, a min and max, looking at the colours again, very important, whether the reds and whites are clear, and whether the face characters are clear and legible at a distance. We have a photograph of the sign, we have a luminescence diagram looking at how the luminance at different test points on the surface of a sign. Then the apron tester. So it's our new luxometer product. So we're demonstrating compliance across a range of stand areas and stands within the airport. So we receive a nice green tick if all of the stands within an area pass. And we can drill down from bar charts into individual tests. So we can see the current test result, see a history of tests. And for each test, we can look at the results at each particular point on the grid, the samples you've taken with the equipment. On our workshop system, I've already said that we have encapsulated tags on the power cables. There's lots of other factors. We've got warranty information. We can calculate mean time to failure. And based on that, we'd like to come up with a traffic light system, red, amber, and green, as to whether that failure period is acceptable. We record the maintenance actions taken at the photo bench. So what you've changed to make the fitting compliant, the lens, the bulb, but what maintenance you've done to the fitting itself, stock management of those parts that you need there. And then we'd like to look at a real world case study. I was going to go over this today, but I feel that we could do a whole TMS Tuesday on this. So we're going to plan one in the future, which is a whole webinar on this subject. So finally, the future. The buzzword is AI at the moment. Everyone's talking about it. How could AI be used in our CMMS? So we've got lots of data. You've seen it in these survey history reports, grids and graphs. What if an AI system could predict future results? How could we use those then to plan our preventative maintenance going forwards? In order to predict those results, first of all, we'd need a lot of past results for the system to learn, which would be our learning set. And we'd also need to consider other data such as weather patterns, seasonal factors, such as de-icing, geographical influence. So which way does the jet blast affect the fittings? Things like resurfacing projects. Take all this into account and pass data, and can the system predict what's going to happen? Iskandela diagrams, we can read them with some knowledge and a careful eye, but could the system read these diagrams to suggest a remedial action, both on the runway and in the workshop? So is it towed the right way? Does it require cleaning? Has it got an internal issue? Is the lamp out? These things, could we have a report that it just lists those actions without us having to analyze the diagrams and just go out and get the job done? Then we've also already mentioned planning our predictive maintenance, preventative maintenance using these graphs and data. Could we get the system to do this for us? Could we automatically adjust our maintenance schedules based on that knowledge to plan our cleaning and talking, replacements, testing, inspections, without us having to do too much to tweak the schedules ourselves? So obvious statements: spending too much time on maintenance wastes money. Spending too little time on maintenance comprises safety. So with all of these tools, we can never replace experience, your experience, but we can provide you with some tools to complement it. So that's my presentation. Thank you. So we'll move on to questions shortly. We did just want to mention our next webinar. In the month of June, we're going to be celebrating 40 years of tailor-made systems and its involvement with airfield safety. So we're planning on June the 25th to have a webinar celebrating this 40 years and what we've done in the field of airfield safety innovation. We need now to go to questions. It's all very quiet.
It is.
Stand by.
Should we go to the panel? Do we have any questions from in the panel?
Yes, I have a question. Or a comment. I think that was a very impressive presentation. A key to the system working as you performed, which does everything, at least if it doesn't do it now, it'll do it in the future, that's meaningful. The first thing we have to do is convince the authorities that oversee the visual aids at our facilities. We have to convince them that a total system, as you've presented it, is of value to them. Here in the States, we know that the illumination levels of the fixtures, I mean, the whole system is built around them being required at a certain level. But we do not basically enforce that happening. We're making some progress. And then I think of the system as you presented it, so much information, and I don't know how the projected cost of an implemented system would be, operating costs would be compared to what they're doing now. But obviously, the information provided will provide a better method of solving problems which are visible now, and the timing of fixing these problems. So I guess not saying too much more. Have we got a document that we could present to the FAA, for example, or to other agencies that show the capabilities of the system, the advantages of the system, and how it's going to make the flying public safer. I mean, if we don't all believe that that's going to happen or is needed, then we're wasting our time. And we've got to convince other people also, even in the agencies, to be convinced of that, because we're not seeing a wholehearted effort over here to think that, well, we got it to 70%, you got 60%, ICAO, I guess, 70, or we got 70% minimum, and it probably should be higher than that with a system like this. And is there a document, or have you prepared a document, or will you prepare a document that is not directly related to MALMS? Because if we have a system over here that the FAA is going to participate and buy into, physically buy into it, then we're going to have a general specification of what this system, phase A, phase B, phase C, will accomplish for the airport. And then, of course, if it was over in the FAA system, they would go out for bids on that. And of course, as I see it right now, it would be based on what your system is. So that's, I guess, I'm just looking for an overall specification, brochure, document that'll say this is the system we ought to be using to properly manage our airfield lighting visual aid systems. That's what I'm looking for. And the videos here are great. I mean, it's great demonstration, and I think they ought to be available for people to look at and get people convinced how good a system it is, or how better a system it is. But again, people, this is a real safety issue. And if we aren't interested in safety when it comes to all this work we do in lighting, if we aren't interested in the end result having good results, then we're wasting our time. And so anyway, that's my statement, I guess. I'd like to see some document that we could use to present to the world that would talk about a system as you've described it, and how the benefits would be related to the airport and safety. Thanks.
I think the closest thing we've got to this, Seward, is the 150534026C. I don't think there's anything in ICAO that comes close to that. But as you pointed out, I think we've discussed this before. We think that needs enhancement somewhat. Yes.
No question about it, and it's way overdue. But I think while that's going on, if we could present them more information, such as we heard today, on what the capabilities are, if we move ahead and upgrade the -26 to and enforce it. I mean, even if we enforce what we got, we'd be better off. But if we could just show an overall picture of what the future can hold, and maybe start integrating that into the 26 that's going to be released one of these months, we thought, and then it's turning into years. But I just think we got to get proactive in getting information like this to them and what the capabilities are. Do you agree?
I certainly do.
Do you agree to that?
Carl?
Yes, I would agree with that. One thing I thought that pointed out well was the attacking the worst 30 first. That made a good impression on me on how to go about correcting the airfield too, is when you get your results, attack the worst 30 and keep progressing in that direction, and you'll get continual improvement.
Oh, yeah.
Yes,
that's great.
I'll make a general comment of picking up on what Seward said. Two things. First of all, convincing people this is a desirable, necessary thing to do. I would have thought somewhere like the IAS annual conference, that presentation would be ideal for, where you get to a lot of people across the industry. It wouldn't be a bad thing for them to be subjected to this information. It could help in changing the climate. the other thing that I think about all of this, you know, having been in business for an awful long time, there is often a reticence on behalf of the end user. Shall we say it's the pilot, or it could be the management of the airport, not to ask for things that they think there isn't a solution to. So they won't ask that the equipment be maintained to a high standard, because their perception is that it can't be done. And how can you demonstrate it couldn't be done? Over the years, I've had often to say to folk, no, don't tell me, you know, you just want a better mousetrap or something. What is the problem you've got? What would you really like to do before I do any research? And I really do see this many a time. Oh, it's no point in. I think pilots can have pretty rubbishy taxiway lighting or approach lighting or whatever. They don't bother to report it because nobody will do anything about it.
I agree. I think a presentation you mentioned to the IES, I think that would be great. Technical presentations at the IES are not to promote a commercial product, but we can have technical presentations which promote a concept and a process. Do you agree with that, Carl?
I do, yes. I think it'd be interesting to have it there.
Can I just say that this is, and this is looks like this is arranged, but you don't know. But I've been in contact with the IES, and this is exactly what I've proposed the paper on. So and that's been accepted by Michelle. So I am doing a paper on this very topic. Yes, but that will be good. And I think I'm just looking. Just thinking, because I was looking at the presentation earlier. I've got a question here from Enrique Sanchez. Says, how to be sure that misalignment is due to light and not to vehicle or measurement system? That's all to do with having an accurate measurement system, and you'll see that if you have an accurate measurement system, and this is something that Sue has been talking about, is actually and we've been trying to do for some time, is establishing a standard for measurement systems. Of course, if the measurement system's working properly, then the measurement is what the light is actually doing, and as part of the test process for a measurement system, that light will be measured independently by a test house to ensure that the readings you're getting from the measurement system are consistent. Clearly, you don't want to get different results because of the measurement process. But I was looking specifically at this on a project this week. It's quite interesting actually, because of course the misalignment it can be as simple as the fact, and I've seen this over and over again, is that installers and airfield lighting teams do not have the tools, have not invested in the tools for those lights to actually set them up level and straight in the first place. And if you don't have the tools to do the job, you're not going to get a good result. And I saw a large number of lights that required realignment, and they didn't have the tools to do them. And that's a real issue for our industry. We must insist. I don't know I mean, you shouldn't have to say in the design document that you must have the tools and you must be trained how to use them. But I feel it's necessary, because this is a repeated issue. And even if the lights actually pass, as Rob pointed out earlier, their performance is somewhat less than it could be, so they will fail earlier. So that's one aspect of it. And the other thing is when we're installing new lights into old cans, something that's not been talked, not people are not aware of, is that if those lights are not the same make and model of the design for that particular can, the actual depth of the fixture can actually leave the fitting sitting beneath the rim of the light fixture of the can, and therefore blocking some of the light output, or in fact being too high and giving a bad sort of a bad fitting from the pilot's point of view, because they're sitting too far proud of the runway. So they're just a couple of things I've seen very recently. And I think if we were to come back to Seward's point, to articulate these in the form of a formal standard document, advisory circular as it is for FAA, and an equivalent document for ICAO, then I think that would be a very good step forward.
I think, Robert, what's becoming apparent to me is that the whole thing of the acceptance test, when a new equipment, new system's been put in, the acceptance process, I think, needs to have something that's completely independent of the people that have installed it. It's no good. I don't think it actually, although it sounds adequate, I'm not sure it's adequate to, even if you say legally, that company is responsible for installing the equipment to specification in terms of alignment and so on. I suspect in practice, they know very well that nobody's going to come after them very much. They'll just sign it off and say, yeah, we've done it according to the requirement. But how do you know? And this is where the MALMS equipment test during the acceptance process could well pick up some very poor installation procedures. I think, if you start off with a rubbish system, you're always going to be fighting it. And I think the airports, and particularly engineering people, ought to be able to be reassured that everything is compliant in every aspect.
Well, in the old days, of course, we would have had, we could have had, it would have been great to see the FAA or ICAO or Civil Aviation Authority fund a research project into this. But what the situation is right now is that our job is effectively, the result of our work is probably the best research there is out there, because that's what we do every day, and we have extensive experience of this type of thing. But we can certainly, we're certainly going to, support airports with a paper of the nature that Seward suggested. But coming back to the questions from the audience, I've got will this system, will the processes we're talking about here work from an LED system? Now, I don't know why anybody would think an LED is any different from a halogen. I mean, the nature of the faults can be different, but the same process will apply to working with LED lights as to halogen lights. It's a process of analysis and measurement and analyzing those trends. Wouldn't you say, Rob?
Yeah, definitely. Yeah. And but it's a slight difference in configuration, isn't there? But so we need to know if they're LED. But yes, so it certainly works for both. The gentleman asked about solar powered AGLs.
Yes, exactly. We've been asked again about solar power. Again, it's a light system, and the measurement of that system will allow us to follow the trends and to analyze the results. And I mean, I'm sure that solar powered lights will suffer from most of the issues, that traditionally powered lights will suffer from, whether they're incandescent or LED light sources. Clearly, the power supply is less stable depending on where you are in the world, but I think and I would suggest one of the aspects we've been looking at, Rob, perhaps you could tell us, where we are with this one is, because with solar powered, you probably want to track the sun and measure the power source, and so you can actually look at the trends according to the measurement according to the availability of sunlight. But similarly, we've been looking at weather conditions in terms of measuring and trending MALMS. Certainly, there's seasonal variations when it comes to, everybody knows about when it comes to insulation resistance, but certainly if you're measuring lights, in particular LED lights, in heavy and torrential rain, when there's no heat to evaporate the water from in front of the lens, that's certainly a factor we need to take into consideration when looking at trends, because there is a direct correlation between heavy rain and poor photometric performance.
Yeah, definitely, we're going to be recording the weather as part of a survey. Going back to old data, the only thing we could do is pick up on a weather server of some sort to see what the weather was at the time. But going forwards, we could get people to record the weather conditions when the testing was done. But and definitely with insulation resistance, as you've said.
And again, coming back to the LED, one of the things with LED lights, when you get conditions, and I don't know if any of the panel can help with this. You get conditions when condensation is far more prevalent, and if you get condensation on a particularly cold night, you can get a buildup of frost crystals on the outside of an elevated LED lens that can also cause negatively impact the photometric performance. But it is pretty. I think it's occurring after a hot day and then a very cold night in the autumn or winter period. That's when I think we're getting these frosty conditions that can lead to a build-up of frost on the granules on the and just a heavy condensation as well can I've had nights where you're trying to measure the lights, and every time you measure them they're failing and they're completely wet. You wipe them clean, and then the moisture, the condensation comes straight back, rendering it very difficult to measure a light that's not heavily condensated, which for a commissioning job is a complete failure.
Yeah, Robert, I think that is important. Sorry, if I may just skip you that. That I think should be addressing the commissioning considerations and standards. And then you look at the levels of the seating rings when you're installing your AGL. And usually, if the seating ring is installed below the design levels, or it diverts from the manufacturer specifications with the contractor or directly done by the airport authorities, and the level of waters sitting in front of the lens is not given a consideration under any situation, whether it's heavy rains or maybe they are doing installations on a dry weather. So when the moistures come and the rains come to increase the levels, and then the fittings get submerged. So this also affects the performance of the lenses when you are doing the commissionings.
Yes, I agree. And seating rings again have been an issue with where we're seeing incompatible seating rings for the lights. I was in the US and saw some plow rings where the plow rings were were designed for they were the wrong plow rings for the light and the actual, and they were obscuring the light. They may be working as a plow ring, but they certainly were not helping. They were destroying the photometrics, and so there is something. It's quite tricky actually ensuring the compatibility of these components when they're put together from different manufacturers. Traditionally, in the rest of the world, the lights are provided. The base is provided with the light fixture itself and any other accessories, all from one manufacturer. But I know in North America in particular, and I don't know why it is, Carl and Seward, but they seem to be purchased independently.
Well, they're sold independently, and that typically, I think, is the light manufacturer has preferred that. Has preferred that they be sold independently, but there is some reasons, and I think that we can make a case for the fact that the light manufacturer may include the base. I think that's something to talk about. And the only other thing I was going to mention, we're talking about the de-icing, or the Arctic kit, as we call it over here, that comes on and gives some heat to the fixture to keep that moisture or any freeze crystals off of that lens. Very few people, I think, and Carl probably can comment on this in the airport. I don't see very many people in the States using this. In fact, somebody from Canada told me they hardly ever use it there. So that's an interesting subject to know, really, do we need it or not we need it. And the third point I have is that here in the States, have the design engineers are very influential to convince the airport that they've got to go this route. But the design engineers could comment on that because the firm he's associated with, they're up to date on all this. But a lot of design engineers aren't up to date on all this data. So that's another group that we have to educate, so to speak. But it's got to start at the FAA level. It's got to start at the top, where
Yeah, I think we're losing
a
Stuart
promise
there.
is a right.
Yeah, sorry, we're losing you.
Okay. Well, I'm a bad location right here. So did you hear any of that?
Yeah. I think it all comes back to the need for the revision of these and articulating these issues in formal processes and procedures that can be adopted by right the way through the industry, from probably covering design through installation, testing of newly commissioned installations, and then maintenance procedures, ongoing maintenance procedures, and enforcing those disciplines, and based on the lessons learned from what's going on out there. Looking at the questions again here, manufacturers continue to evolve their products and introduce innovative products. LED PAPIs with white, red LEDs in different planes. Does innovation cause difficulties when using information collected by MALMS in its analysis? No, I think we have, when we measure, we're measuring light, and what we measure is it may be whatever the nature of that light, that's what we measure, and that's what we form our judgment on. The actual technology that goes into it, well, clearly you need to, there can be circumstances. I remember when LEDs first started, there was an instance of where pulse width modulation was being used. There was some of the early LEDs had a very slow modulation, and we drive so fast down the runway, we did actually come across a situation where we had to adjust the the data capture rate to adapt it to a particular fixture. But then that was one of the early fixtures, and that's never occurred since. But even in that circumstance, we were able to update our calculation models to function in that particular situation. So I don't think I don't see it's always a challenge. There are some new lights at the moment coming out with that can change color, so you can actually they can be different colors. So clearly, we have to figure out, if we're going to measure a light, we need to figure out what you measure it against the standard. So but the question is, what color is it actually you actually going to get when you put it on a bench tester? And so yeah, there are issues. Solar powered lights, for example, because clearly putting those in a bench test, there's not a lot of sun inside a bench tester. All these things can be overcome, though, with working together with the manufacturers. ICAO document 9157 Part 4 provides a very limited description of how to perform tests of runway guard lights and the challenges due to the flashing characteristics. Can you provide some information on this? I certainly, if we're looking at flashing lights, I know we can certainly measure the flashing lights, but we can't. But that's specific detail. I'd need to research what the issue is there with that one. If Emmanuel, if you could let us know exactly what your problem is, and then we can answer you specifically for your situation. Does anybody have anything to add on measurement of runway guard lights and the flashing characteristics?
What?
No. Right.
You got to know the frequency, and you got to be able to discern that the frequency of the guard lights as they alternately flash is correct. Did you hear that?
Yes, absolutely. And so again, these there will be challenges, but we've always managed to meet those challenges, and it's part of it's always an interesting part of the job to actually figure out how to deal with new technologies. I mean, we've modified our power supply several times on the photo bench because the changing demands of LEDs and some of the particularly low voltage LED systems, and I can see there'd be more of that coming in the future, because it would make sense to have Carl, there's a project the FAA is engaged on. They're evaluating, they're looking at 2.2 amp systems. Is there, Carl? I can't see on my screen there if Carl's still there, but Carl appears not to be there anymore. But certainly the FAA is engaged in a research project to determine an optimal form of LED power supply system that could that will effectively become I think the standard for the industry if that project's ever concluded, because that will be a prerequisite for the funding plans, the funding that FAA provides. And if you don't comply with it, you won't get 90% of your cost paid for, which means they're not going to be purchased. Do we know where that project's gone?
When it comes 10 years ago, we did a project with LEDs, operating them on a It was, I think, it was less than 2 amps, less than 2 amps. And it was a 3-step regulator, and we went down. I remember the step 1 low step was like 600 milliamps or 300 milliamps in the circuit. And we did
Yep.
that, and we operated the system. But I think they're doing more work since then. And but that's an ongoing thing, I'm sure.
Right. Okay, well, that's certainly something, you know, that's something that we need to keep a watching brief on. And I think needs to be reflected in the, you know, to the extent that there are these new things coming out, we need to consider the implications for the designers, the installers, and the maintainers, because it's not for them to figure it out when this new stuff's been put out there on the market. That should be considered up front, and there should be proper guidance provided so that we know what we're doing, not we've got to go and figure it out.
Right.
Okay. We covered, there's 101 things to be talked about here, but I think the big takeaway from the conversation today is that what we need to do is to actually embody these things, a more scientific and analytical approach to our installation and maintenance work in the standards. Initially, I know Seward's been talking to the FAA about the 150534026C maintenance standard. I don't know if that came up. Is there? We're talking about. You were talking about a group, a formal liaison with the FAA on developing this matter. Was anything agreed? Are we doing anything?
No, I haven't. I contacted the FAA and the concept, and so yes, and I've heard not a response from the FAA. And so, you know, and it's to get the FAA to use IAS or other groups or other associations or a group of people who are technically knowledgeable in a particular area to work with them developing the standard. And we used to do that years ago, but we don't do it anymore. And we need the FAA's agreement that that's a process which they will use. And we need that before we can get the people in industry to buy into the time and effort it's going to take to fulfill that obligation. So we're waiting for FAA to do this. And the only other comment I had, there's a lot of good points presented today, Robert. A lot of good points. I would have somebody go through the recording and do the key points which the industry needs to do at this stage to promote the proper measurement and maintenance of these lights and installation. We just listed a bunch of subjects. Just list those, and then we work from that.
Good suggestion. Well, Kev, I think we're drawing to a close here. We've gone to we're 24 minutes past our time, according to my clock. So I think we'll wrap things up here, guys. Kev?
Yeah, I think you're right. Thanks, Rob, for a very interesting presentation. And we'll look forward to seeing everyone on the 25th of June.
Thank you. Thanks very much.
Thank you.
Thank you all for joining us. Thank you. See you all soon. Have a nice month. Bye.